All right, guys. So hello and welcome. This is going to be comparing point cloud services for a civil workflow. I'm your host, Josh Hunter, along with Terry Radman. And we're both members of, well, I'm a member of the reality capture team here at ATG USA, and Terry's a member of the civil engineering team. So if you're joining us live today, you'll receive an email with this recording and other helpful resources after this event. If you're joining us after the fact on YouTube, by all means, just like all those lovely influencers out there, please like and subscribe so you can get all of our further content coming down the pipeline. So without further ado, let's get started. So let me do the good old share the screen here. All right. So as I mentioned before, comparing point cloud services for a civil workflow, we're going to be looking into InfraWorks, Civil 3D, and good old Autodesk recap. First and foremost, like I mentioned earlier, my name is Josh. I'm a part of the reality capture specialist team, or the reality capture team. I deal with laser scanners, drones, and all that good stuff. So that's where I'm kind of coming into this conversation, is the point cloud part of it. We also have Terry Radman on the call as well. Like I mentioned earlier, he's on our civil team, and he's going to be showing you all the kind of meat and potatoes on the civil side of what you can do with these point clouds. So as I mentioned earlier before, by all means, we have an awesome social media presence, both in LinkedIn and our YouTube. On our YouTube page, we have a lot of neat reality capture workflows. We have Civil 3D, we have architectural, MEP. We kind of got you covered all different ways there. So by all means, if you're looking for some awesome free content, please stop by and subscribe and enjoy all the freeness. So as well, let's talk a little bit about the company here, ATG USA. We are an Autodesk reseller. We do a full gambit of everything. Like I keep mentioning, I'm from our reality capture department. We have a full civil team. We have a full architectural team, MEP, you name it, we do it. We can sell you stuff. We can sell you hardware. We can sell you software. We can come out and do the work for you. You can give us work. We'll take care of it for you. We'll partner with you any which way we can. So by all means, if you got some time, please stop by ATGUSA.com and give us a check us out. So, all right, the agenda for today, real quick, like I said, I'm going to be going over kind of the differences of the point cloud data. From there, what you can actually do with it, that's where Terry's going to step in and be the master of all that goodness. He's going to be creating existing ground services and the many different ways you can do it. Create service from point clouds, map, create, Pct Surface, InfraWorks terrain, point cloud terrain, and then obviously compare all the different results there. So we got a lot in store for you guys. So as far as questions goes, guys, by all means, at the end, we're going to dive deep into any questions you may have. With that being said, in the meantime, while we're talking, if you want to type them in chat, by all means, please do, so you don't forget or miss anything. So by all means, throw them in there, but we won't really address them until the very end. So once Terry's done, he'll let us know, and then we'll dive into any of the questions. And that can be the full gambit here. It can be on the reality capture side with what I'm going to go over, or it can be with what Terry's mentioning. So, but all right, so let's dive in here. I'm going to get into the drone stuff. So in this realm of things that we're going to be talking about, the point cloud, as simple as it is, everybody kind of knows what the general idea of a point cloud is. There's two different ways you can go about doing it in this space, in the drone world. We have photogrammetry and we have LiDAR. So as you can see, LiDAR, which stands for light detection and ranging, is a remote sensing method that uses light in the form of a pulse laser to measure ranges, variable distances to the Earth. So think of it kind of like sonar. It shoots out a laser, it hits something, and by the time it comes back, there's an equation there that'll give you the time and distance and everything like that. So, and that's what everybody knows as far as your typical terrestrial tripod scanners. That's what we use is LiDAR. Drone photogrammetry uses images captured by a drone-mounted camera to reconstruct the terrain in an accurate 3D model using image overlap and sufficient ground control. So what that does is this very last sentence, which is the most important, each pixel is designated a point. So what it's doing is it's flying over and it's taking hundreds and hundreds and hundreds of pictures and designating points to each pixel within those pictures. And I'll get deeper into that here in just a moment. As far as the LiDAR side of things, some of the benefits there, when surveying land with dense vegetation, so we're talking forests, lots of trees, woods, or if I'm in the good old Southwest here, so cactus and everything like that. Photogrammetry is not going to be your go-to there. You need something that's actually going to kind of penetrate all those different, leaves and limbs and trees and everything like that. So again, with dense vegetation where light pulses can still penetrate between branches and leaves, LiDAR yields a high vertical accuracy. This is a significant advantage over photogrammetry, as photogrammic surveying will only produce high vertical accuracy when there is sparse vegetation on site. So obviously, if you're doing a building or something without, trees and green stuff, you'll be fine with photogrammetry. LiDAR is always going to be a little bit tighter, a little bit more precise than photogrammetry, but as I will go into in probably the next slide here, you will notice the big difference between LiDAR and photogrammetry is the cost. But staying on LiDAR right now, while LiDAR does have similar limitations, it can penetrate areas with up to 90% vegetation under good conditions, compared to photogrammetry, as you can see here, is about that 60% mark. So really good for the forest industry and everything like that, or if you are flying a long a lot of acreage and there's a lot of vegetation out there, LiDAR is going to be your better bang for your buck here. It's really going to save you on the back end, because you're actually, when you look at a photogrammetry point cloud over something that has vast vegetation, it looks like broccoli. You just see a bunch of green kind of clumps. You're not actually getting to the ground and you're not getting sufficient data there for what you need. As far as photogrammetry, first thing, like I mentioned on the previous slide, costs. LiDAR-based drones can set you back easily $50,000. So the drone itself, anywhere $5, $10, $15, $20,000, if not more. And obviously you have to carry that payload of the LiDAR scanner, and that's the other significant cost here. Whereas your typical quadcopter drones, like your DJIs and things of that nature, start at just a couple $100,000 there. So with the right processing software on the background, you can take your typical drone that you got over the counter at Best Buy or wherever you got it, Amazon, and you can actually do quite a bit with the photogrammetry side of things there. LiDAR does give you a point cloud, but because of photogrammetry stitches photos together, you actually get to, while you're creating this model, you have a better visual detail. So don't get me wrong, when you have a LiDAR scan, yes, you are looking at millions and millions of points, and you are able to see a picture and okay, this is a tree or that is a wall. But when it comes to photogrammetry, since you're stitching together all of these photos, you actually get better visual details on every feature on the site. And like it says here, it's taking that abstraction out of it. So there's plenty of times where we'll take a LiDAR scan and we're trying to understand what is that? What are we looking at? And you're having to move it and change different, intensities and all these different things just to figure out what that is. Whereas when you're within a point cloud based off photogrammetry, you immediately know what that is. It is a photo of that. It's a very clear indication of, hey, that's a light switch, or that's a tree, or that's a, whatever it may be, a light post. You know exactly what it is. And having that vast detail is really, really beneficial for a lot of people. And to carry off that, like I just mentioned, photo-based models can also be used to verify what feature you're seeing. When it comes to fine detail services and features, LiDAR can be unspecific. You might find yourself unsure about what exactly you're seeing, just like I mentioned. So, all right. So with that being said, just throwing a little plug here with our BIM boxes. So in the realm of anything architectural, reality capture, civil, MEP, you name it. If you're in this AEC lovely world, you definitely need to take a look at our amazing BIM box computers. They will run circles around almost any machine that you have currently. And I know some of you are probably rolling your eyes there saying, oh, my machine's pretty awesome, but I'd love to test it against ours. So by all means, give us a call, let us know. We'd love to talk to you more about our BIM boxes. We both have PCs and laptops, so I just wanted to give you a nice little plug in there. So. With all that being said, I am going to throw this over to Terry now, and what he's going to do, we have a couple different data sets that we're actually going to go into, point cloud data that he's going to take into InfraWorks, Civil 3D, and do all of that fun stuff. So without further ado, Terry, I pass it on to you.
Right, thank you, Josh, and welcome all. Appreciate your time and attending our webinar here. So I'm going to start out with the photogrammetry data that we have. We're going to also look at some LiDAR data, and really two things that are common between the two are whether the data is classified or not. When we have LiDAR data, we'll usually have a classification that's associated to each point. And easy way to tell is just the color of it. Obviously, photogrammetry, like Josh mentioned, you get a really nice looking image of your terrain and the environment that you're scanning. And so what we're going to do is we're going to go through recap. I'm going to take a chunk of this scan here and bring it into InfraWorks. And from InfraWorks, we're going to run a couple commands that will actually classify your surface, and it'll kick out another recap file as well. Note that new versions of InfraWorks, I think it was 2020.2, you can now bring in straight LAS files into InfraWorks, and it will process that into a recap RCS file as well. So with that, I'm going to go and show you some of the scans that we've done here. This is a scan of an area in Arizona here, and we have terrain. We have a really nice image of the vegetation, the terrain, and just the environment in general. You can see high detailed of the cars, buildings, vegetations, even the terrain and the cuts in the road here. And so what we're going to do is we're going to take a piece of this out. One of the things that I wanted just to mention before we go over this is just the coordinate system. A lot of times we're pulling data from USGS and different resources. And one of the things that the end result, when we get to making our surface in Civil 3, we should be setting our coordinate systems to what we're designing off, or what we're intending to use the data for. And when we bring that into recap, there's a function in here that we can set our coordinate system on importing. And let me go ahead and just show you here. So if I just start a new project, let's save this one here. Going to call it test here, and I'm going to start a new project. And when I drop in an LAS file, I'm just going to bring in this this LAS file. Before we go to the next step, before we import our file, we can go up here to this advanced tab. In this advanced tab, if you're reprojecting your data, let's say we're getting our data from USGS or some BLM, some other source, we'll want to know what their target and their current coordinate system is. If you already know the data is in a specific coordinate system, then there's no reason to change it. This is really just for reproject, but just be mindful when you bring in your data to definitely check to see what your coordinates is. because it also deals with units too. A lot of times you might get something that's in UTM zone that is in meters, and you'll want to make sure you select those, and then your target coordinate system. A lot of times here in the States or in Arizona, we're using state plane coordinates, and that is in feet, and we can set that coordinate here as well. So just be mindful on this advanced tab before you import your data to definitely check if you're reprojecting your data to a different coordinate system than you're actually going to be working in. All right, so let's go ahead and open this. So really straight, easy, simple, straightforward to reduce this. There's some editing methods. We can reduce points out of recap. We can clip this image out. And so what we're going to do is we're just going to take a chunk of this just to save some time on processing once we get it into InfraWorks. But let's have a look at our model here. So we have a lot of vegetation in this area. We have our trees. We have some vehicles here. And what we're going to do is we're going to classify this data. And what I mean by classify is it's going to go through a process where it will identify what is a ground point and what is a vegetation point, and classify the point so we can actually extract the ground. When we're dealing with models in Civil 3D, we're usually using LiDAR data to supplement survey, and we're taking the data and we want to reduce it to existing ground. And so really that is the process that we're looking at is we don't want trees in our existing ground surface, because when we do a compare surface between those two, we'll get unexpected results. And so I'm going to go through here and we're just going to clip out a piece of this data set. So let me just get in here and I'm going to try to get this building and this pad here. And so in recap, pretty simple. We can draw a window. I'm just going to draw a window around our building here in this pad, and we'll select these objects. Once we have this selected, you'll notice that there's a menu that pops up that has options to clip the data. We're going to go ahead and clip the data here and clip the outside just so we get this this area here. So just so you know, when you're clipping the data and recap, it is basically just hiding the data. It's not actually physically removing it. It's just showing it off screen. But when we do this and we export it, it's going to take the extents of our area and export that as a new RCS or RCP file. I tend to use RCS. And so if we go up to the menu here on the top, we can go to the export import button, and we're just going to go ahead and export this out. And I'm going to just save this to my directory here, and I'll just call it site 1. Sorry for my bad naming convention, but we'll go ahead and export this out. So what it's asking is if we want to unify scans. If we brought in 2 different data sources, 2 different scans, and they're tiled together, basically what this is doing is putting the scans together before it exports. And so since we have 1 scan, we're just going to go ahead and let's do this, and let's go. All right. So pretty straightforward recap. Take our data in, have a look around in our data set, clip any data you want, merge any data sets together, and export it out as a new RCP file. So once we got that, I'm clipping my data just so when we bring it in InfraWorks, it doesn't bog down my machine. And when we process the terrain, I have the terrain already saved here, but I'm going to go back to a different model. So I'm going to go back to our site. It's just a blank drawing here, our blank InfraWorks model that is set up. And again, when you create models in InfraWorks, be mindful that once you set the coordinate system, or once you create a new model, you have to set the coordinate system. And after that point on, you cannot change the coordinate system per that model. At least that's what it says when you create the model. So with that, easiest way to do it is to just drag and drop. And I have exported this out to my folder here. And so I'm just going to take my recap site 1 recap RCP file and drop it into my map, and I messed that up because I did not change it to an RCS file. So let me go back to recap And I'm going to re-export this. Sorry about that. Cancel. Back. Suspend. Go back here. And I'm going to export this again. I'm going to change it down here to an RCS. And I'll call this site 1. Let's do this again here. All right, so really there's 2 different approaches. If you go, you can drag and drop this in. The other option is if you go to your data content, if you go to this little arrow down, you can go and bring in your point cloud data here as well. And I'm just going to take my RCS file and drag it into our map here. And that is not wanting to work. So I'm going to go and create a new model. Here's UTM zone here. Get that to work. Let me try this one more time. And it always happens when you're live on a webinar. So let me bring in, see if
Technology is great when it works.
Right.
Pain when it doesn't.
Thank you. Okay, so I brought it in through the menu. For some reason, it didn't like my first approach, and I'm going to go ahead and bring it in through the pull down menu here in Point Cloud. So once we bring it in, we'll need to configure it. If you double click on it, basically we'll set the coordinate system here, and then we'll close and refresh. So we're going to use UTM zone for our data, and we'll close and refresh, and we have our model in here. And eventually it will populate. All right. It's probably going to be right here. All right, so we have our model in InfraWorks. It's still point cloud data. And with that, if we zoom in, you can see our points. We have a lot of vegetation in here. And what we're going to do is we're going to process this to extract the ground points out of here. And so with that, we're going to run a couple tools and see what the results are. Really, when we run these tools, it's going to extract the, it's going to basically classify the data. So what we're going to do is we're going to, with our point cloud, we're going to process it into a terrain. And so on this point cloud menu here, we can go to our point cloud terrain. On our point cloud terrain, we have a couple options. We have optimal. It's basically going to go optimal, more detail or less detail based on your point cloud and the data. And it's really just relative to the size of what your output file is. So I'm going to leave these as defaults here and leave the lightweight as default here as well. We can do all points or key points, and we're just going to leave it as lightweight. And what we're going to do is we're going to export this process to build the terrain. And on this export processing, we have a couple options here. And this is what we're going to do. We're going to use the ground only point. So we're going to build the terrain, and InfraWorks is going to try to figure out which of these points are ground points and build a terrain from that. So I'm going to go ahead and start processing this. Actually, I'm not going to start processing this because it's going to take, I think it was about 8 minutes, but on this data, I'll show you the results here in a different model. So these are the settings that I normally use to build my terrain model. And I'm going to show you what the results are in InfraWorks just to save some time, because it did take a little bit to get that result. I think it's going to be in site 1 actually, but from here. All right, so this is the process that built the terrain model. If we look here, we still have our points, but what it's done is it's done its best to remove the ground points. Yes, that does not look good. This is what the result usually is. If you have high vegetation, a lot of times what we end up doing is taking this back into recap and manually remove points, because we can see here that it's removed some of the vegetation, but it's left it looking our surface like a Mars a Mars surface with rocks protruding everywhere. So one of the things that we run into is, running this process, it doesn't do the best results. When we're dealing with photogrammetry data, it is like Josh mentioned, it's grabbing a lot of the vegetation and it's adding those points to it. And when we process this in InfraWorks, we really get not a good result for it. So what we can do to fix this is there's a couple different options. We can take this back into recap. We can clean it up manually just by deleting the points, by selecting them and deleting them, and then bring it back into here, kind of the iterative approach to get our data to look right. But the other thing we can do is we can take this this point cloud into Civil 3D, and there's a couple methods that we're going to get into to show to bring that data in and reduce the points. And what it'll do is look at the points that are adjacent to each other, and if there's an elevation difference, it'll remove those, and that is basically called the kriging method. So there's two options once we have this built, and I wanted to show you them because one thing I mentioned, when you run that tool, it's going to create this point cloud derivative directory, and inside here it's going to build that point cloud, that new RCS file. So what it's doing is when you drop in the RCS file and you run the process to create the train, be mindful that it's writing out this extra RCS file with the results of what you have done with the terrain model. So what I'm going to do is just bring this into Civil 3D, and we'll look at the results, and then we'll look at some other data as well. And we're going to look at some classified data, and with that classified data, I tend to not bring it into InfraWorks because it already is classified and I can remove those points. So with that, I'm going to go ahead and prep on that, and then we'll just move over to Civil 3D. But be mindful, it builds this RCS file. There's another approach to exporting this data out as well. And on the Share tab, there's this IMX file, and we can export the IMX file out as well on here. And basically, we would draw a polygon, and we'll select some points and just kind of draw in an area that we want to export this data out, and go ahead and click on point up here, and I should double click to finish, and then we can export this out as an IMX file, and we can bring this into Civil 3D as a surface as well. So I'm going to go ahead and just run this. We can look at those two different results between the surfaces as well. All right, so I'm going to go back to recap, and I'm going to open up another project here, and I'm going to show you what some classified, or actually LiDAR data looks like in here. So I'm going to take a step back, and we're going to go to this other recap project. All right, so this is some data that if you get LiDAR data from city, county, your state agencies, usually it's already classified data. This how this is showing is just a representation called intensity. How we can change it, the raw data, if we look at RGB, it's going to show us what the raw data looks like. And so with LiDAR, you're basically getting a color range more than just an RGB or even a photo looking imagery. So there's some, it obviously doesn't look as good as some of the drone flown data, the photogrammetry data, but in context, it's better accuracy, as Josh mentioned before. And so I'm going to take this data, and I'm going to do the same process. We're just going to cut out a strip of this. So I'm going to go ahead and select an area. I'm just going to select this building and the roadway here, and we're going to clip this out. And then I'm going to take this and export this data out as well. And I'm just going to name this building site. And I'm going to change it to an RCS file, and I'll put it in the folder there. And then we'll go ahead and process that.
And
All
again,
right.
like you're just to piggyback off what Terry was saying and what I mentioned earlier, photogrammetry is its niche is more going to be in the architectural world. If you're going to be scanning buildings and structures of that nature, where you're not having a lot of vegetation, as that LiDAR scan, like Terry said, it's not as pretty as what you see in a photogrammetry, but you actually got the penetration through the vegetation and actually got to the surface. So you don't have that Mars-like kind of atmosphere that you have in that photogrammetry data that he just showed, which, as Terry knows as well as I do, and many of you guys watching, to kind of fix that photogrammetry data is a lot of time on the back end and recap, where you're meticulously going through and making sure you're deleting the vegetation and not the ground. And even underneath the vegetation, there is no ground because it couldn't penetrate through the vegetation. So again, for what you got, what a lot of in the civil world, a lot of times if you're doing large acreage, large land masses with vegetation, it's LiDAR or nothing, because photogrammetry is just going to be too much work on the back end to not get as accurate as data you might need. If it works within your level of accuracy and what you're looking for, great, photogrammetry can work for you. But as you can see on the data here, LiDAR is kind of where you want to be, in this regards as far as that point cloud. And Terry can attest. If I said, hey, Terry, I have a scan of this data, I have a photogrammetry scan, and I have a LiDAR scan, 9 times out of 10, he's going to say, yep, give me that LiDAR scan, just because it's going to have that penetration. So,
right. And yeah, if you guys on the webinar here have used other tools to process or classify data, let us know. Post it on there on our chat. I know a couple folks that used, I think, Global Mapper, and there's some other tools out there that can run your photogrammetry data and do a pretty good job processing the ground surface as well, and then even creating a grid surface, you know, a 2-foot or 1-foot grid surface on that. All right, let's go ahead and get started here. I'm gonna start with the data that is the LiDAR data, and we can look at those results. So in Civil 3D, again, you know, we all want to be mindful about coordinate systems and how we bring this in. So I'm going to go ahead and set my coordinate system. So on the settings tab, I'm going to right click on my drawing, set coordinate system. And I know my data is in Arizona Central feet. And so that's what I'm going to set for my coordinate system. Because my LiDAR data is in there, it came from the county, and it is what I'm going to be using for my construction documents on my submittals, and so that's what I'm going to use in here. So I'm going to go ahead and go to my U.S. Arizona, and I'm going to go ahead and use Arizona Central Zone International Feet Harns coordinate system, and I'm going to set that coordinate system. All right, so there's many methods of importing the point cloud in here, and I'm just going to go through the easiest method, which is the XREF. You can XREF your point cloud, and it's no different than if you go to insert. I think there's another point cloud, attach point cloud here as well. It's basically the same function. So I'm going to go here and click on attach point cloud, and I'm going to attach, let's see here. I'm going to go ahead and attach, and now I have, this is the right directory here, this building site RCS file here. Okay, so I'm going to bring this point cloud in and attach it, and just attach it as an XREF and bring it in. So one thing to be mindful of is when you bring in a point cloud into Civil 3D, the first thing it does is it changes your view to a 3D wireframe view. And the reason why it does that is because the point cloud will not show up in Civil 3D if you have it as 2D line work or our standard image setting here, our visual style here. Okay, so with that being said, there's a couple different approaches that we can do to create this point cloud into a surface. The easiest approach is just using the stock commands. If you highlight our point cloud, we can do this point cloud from Civil 3D surface. So we're going to do this approach, and then we'll try another approach here. So this guy here, we'll go ahead and click on create point cloud surface from point cloud. I'm going to be generic and leave the settings here for my name. I'm going to go ahead and hit next. and it gives me some information about the density and my points, the amount of points that are in my clipped point cloud here. And so these are the two methods that I mentioned earlier, the kriging method and a planar method. And these are the how it's going to determine what points to remove. Obviously, the planar method, when you look at the example here, it looks like it's not going to do a very good job. It's showing that it's just taking a plane, and if you have rolling hills and a terrain, I'm sure it's probably not going to work very good. So I hardly use this method, and I use the kriging method. And so with the kriging method, it's looking at adjacent points and looking at the elevation jumps between there and trying to figure out the best point for the ground surface. So with that, I'm going to go ahead and just create the surface here from our point cloud, and it's going to work on in the background. Once that's being processed, I'm going to show you a different approach, and this is the approach that I commonly use to create the point cloud. And the reason why I do it is because we can extract the classification out. Right now, when I just created the surface using this tool here, it's basically going to look at this building and look at the points adjacent to it to find out if it's ground or not. It's not the best approach, especially when we're dealing with classified data. And so I'm going to open up another drawing here, and I'm going to set my coordinate system, and I'm going to bring this in one more time. And this time I'm going to use a map function that's called map create Pct Surface. And what it's going to do is it's going to create a Geotiff image of our data, and a Geotiff image that we're going to use to assign to our surface. When we talk about Geotiff imagery or even raster-based elevation data, commonly used in GIS functionality, so in ArcMap and other processes, when you develop hill shades or when you're running through LiDAR to surface, it's basically going to create a raster or a grid file that it uses for its elevation. So again, I'm going to go ahead and set this coordinate system up here, and then I'm going to go ahead and attach that file again. I did drawing. That's why I defaulted to the wrong folder. Okay, let's go ahead and bring this guy in. All right, so with that, there's a command that's called map create PC for point cloud surface. This command here will create the Geotiff. So once we run this command is actually a AutoCAD map command, but as we all know now, AutoCAD map is embedded into Civil 3D, and we can always go to this menu and go to the planning analysis menu, and that is the GIS functionality that Autodesk has to deal with some of the spatial, I would say not spatial analysis, but more the GIS functionality. So what we're going to do is, since it's already exposed in Civil 3D, we're just going to type in the command. Map create Pct Surface. We're going to go ahead and select our surface here, and we'll hit OK. So what this is going to do, it's going to create a Geotiff, raster-based image, and with that, we can look at the data. Actually, before we even do that, let's just look around here. Let's look at this building, and we can look at the elevation of the top of the building. So this is a direct scan looking straight down. We have some buildings that are in here. Obviously, we don't want that into our surface, and we want just the ground points. And so what we're going to do is, when we run this this tool to create the Geotiff, we're going to specify a classification that we want to only extract into the Geotiff. So I'm going to click on the edge here, hit OK, and then I'm going to go down to this filter command. So if you look at this filter command, these are standard classifications, if I'm not mistaken. Is that correct, Josh? When you see a classification of data, you know, ground is going to always be 2. We have low vegetation, medium vegetation, high vegetation. We have buildings. These are each point has a classification, and it's these are standard numbering systems for these classifications. So what we're going to do, Yeah, thank you.
And Terry, I apologize to cut you off or intervene here. So I know that we were saying that we're going to kind of keep the questions to the end. We have a couple just a question right now from Adam, and then also I believe Jasper just threw something into the chat as far as,
Yeah.
I just want to kind of answer it now while we're in this instead of out of context later. But yeah,
Let's do it.
What happens if you use the no filter option? Also, when you upload the point cloud in InfraWorks, do you have to export it when you are done? And what options do you select? And before you jump on that, I believe that Jasper said, is there a reason why you wouldn't use no filter for creating a surface from point cloud? I typically use this when creating a surface from point cloud, but my point clouds are usually ground only already. So just, I'll let you take off with that. I apologize to interrupt. I just kind of wanted to kind of answer while we're right here. So
absolutely. So what happens if we don't use a filter for ground points? In my case, our ground surface, our existing ground surface that we're trying to create is going to use the buildings as the ground surface. So if I ran this through, and we can just do it real quick, we can run this through the ground surface. But what it actually does is it's going to take any vegetation, any buildings, and it is going to be part of that surface because we're specifying no filters on it, and it's going to take that everything that's on this is existing ground. So what we're going to get is the same thing we got in InfraWorks with the the Mars looking ground, because every tree in here is going to be a lump on our surface. And so that's pretty much the results you get. And also, when you upload the point cloud to InfraWorks, do you have to export it when you're done? You don't have to export it, but what we're using InfraWorks is to actually build the terrain. When you bring in the point cloud into InfraWorks, it's still only a point cloud. There's no terrain model. There's no surface. It's still just a point cloud. It's visual. If you wanted to use like Model Builder and bring in the data that comes in with Model Builder, which is USGS data, and then bring in your point cloud, you can take that approach too. But just remember, it's still only a point cloud until you create the terrain data, and then what it's doing is building that RCS file and building the surface. And then once you have the surface, you can export that out. So if we look at this, this is actually the surface that we can see in here draped, and you can see where we have shadowing where the drone did not catch the shadow or the image, and so the image is not draped over here, and so you have all these holes. But it's smart enough to know, or even this could be a bush that it didn't penetrate the ground, and so it's still going to build the surface underneath it. But this is the terrain that we're using. So the gray areas in here are the actual terrain, and when we process it through there through InfraWorks and build the terrain, it's actually building a couple different data sets for us. So what it's doing is building the raster out of the image of the point cloud, and then it's building the actual terrain overlay. So the gray area is the terrain overlay, and the raster is the raster data. And if we wanted to, we can actually delete the raster data out of here or just turn it off, and we should see our point cloud, and then more importantly, our actual surface in here. I don't see the surface, so I think I deleted the wrong thing. Oh, maybe it's right here. So there's our point cloud, and this is the actual terrain surface. So I hope that answered your question. Let me look here and see if there's anything else. So the exporting, really, there's two options really. There's the exporting the IMX, and then exporting or just using the RCS file that it builds when you build the surface in InfraWorks as well. All right, do you have something you wanted to answer on here, or should we move forward?
Oh, yeah, actually, I just sent Brian a message saying that I'd answer it at the end, but I can answer it right now, actually. Okay. So I appreciate that. So yeah, Brian, as far as we don't really have too many clients who are doing large vegetation areas with photogrammetry. Have we done it in the past? Yes. Because at that point we didn't have the right tool for the job. We didn't have a LiDAR drone. But it all falls into that level of accuracy that your client or customer are looking for. In this particular instance, the customer was needing roadways. Yes, there was some vegetation and some desert and things of that nature. He really was just looking to get a not 100% accurate surface, so that kind of Mars-esque like data set that we showed you earlier. He was okay with that because the areas that he really needed the data, the photogrammetry was fine for. 9 times out of 10, if I'm talking to a customer that, you know, they're saying, hey, we need this flown with the drone, and they have pictures, or we look it up on Google Earth and it's very heavily a lot of vegetation, we try to go more of a LiDAR route with those people. If you're in the situation where you only have a photogrammetry drone and you don't have the money to, or the, you know, the budget for, I should say, you know, stepping into the LiDAR based drones, if you have any terrestrial scanners, there's kind of some neat, unique ways that you can kind of do the best of both worlds. So what we have done in the past, where we had the photogrammetry drone fly overhead, and we actually took some larger scanners, in this case an RTC 360 or even a P40 or P50, and actually kind of went through on the ground and got some pretty extensive you know, more long distance LiDAR scan. So it was better for the surface, but then we were also, because it was such a large area, we were getting a lot of the photogrammetry, and we kind of meshed that, we kind of tied them together. So there's some unique workarounds, but again, it's also what equipment you have. So to kind of answer your question, a lot of times if a customer, like I said, is like, hey, we have this big area, a lot of vegetation, I tell them, here's what we can give you photogrammetry, here's what we can give you LiDAR, and 9 times out of 10, they're going to lean more of the LiDAR route just because of that penetration through the vegetation. But like I said, if you can be unique and kind of think outside the box, and you have a terrestrial tripod scanner, you can throw those in and spread them out, and kind of do it in a neat little kind of grid way, and then have the photogrammetry, and they come together pretty well. But again, that's if you have the tool. So hopefully that answered that for you.
All right, excellent. Thanks, Josh. All right, so we're going to build this Geotiff file. We're going to extract just the ground points, and I'm going to hit OK. And then we're going to go back and we'll create another one with no classification or no filter on here. So I'm going to call this building site underscore N2 just to be identify the classification. And I'm going to export this out to a Geotiff. All right, and so now that that is exported out, we're going to use it to build a surface. So easiest way to build a surface with the Geotiff is basically creating a surface in your prospector here and create the surface. And I'm going to call this EG because that is the closest name to what I've extracted. And I'm going to hit OK on here. And so once we build, all I did was build a container. It's the surface container. So now I need to assign the Geotiff to it. So I'm going to drill down into our surface and go to the definition. And under this DEM file, this is what I'm going to use to add the Geotiff back into our model. And so here's our Geotiff ground 2. I'm going to, Geotiff ground 2. I'm going to hit OK on this, and then I'm going to hit OK on this. And since we are in point cloud, the surface might not show up, but we'll go ahead and go back to our wireframe here, and we'll zoom out, and we'll look at, here's our surface here, and we'll look at the results for our surface. And I'm going to go ahead and detach my point cloud because I really don't need it now. So just go ahead and detach that, and we'll create another surface with that. And I'm going to go ahead and put this in a realistic mode, and we can have a look at the terrain data on here. And what I'm going to do here, let's just do this. Let's go back, and let me go to our wireframe. And let's go ahead and look at our contours. And let's go ahead and let's since we have our coordinate set, let's just turn on some the geo maps here to bring in a Bing imagery. Let's see if we get this to line up. All right. All right. All right. So Here's our LiDAR data. We can see our slopes in our road. We can see the road is following our contours. We have a pretty good slope down here. There's a little valley in here as well. And then we have our buildings. And so we have this building here, but it did not build the surface, our ground surface, to traverse or go over this building. So we're using that, that filter really helped us on that. So we take this and we actually, we'll just look this around. I don't think it's going to keep the image, but we can look at our terrain here of our surface as well. So that's one result. I'm going to show you one other result with this here. I'm going to go ahead and turn off my GeoMaps. And we'll turn that off and look at our contours here. So one of the things that we do, since this LiDAR data is so dense, is we can make some edits to it to reduce it and to smoothen it to make our contours look more appropriate. So just be mindful if you go through your edits, you can smoothen your surface as well. And you can actually trick your surface by going to the surface properties and making your surface more round. I think it's under the edit options. There's a not a simplify, but there's a way to, I think it's actually in the style where you can make your contours not so jagged. But so this is one approach to build it. This is the approach that I normally use. So let's go ahead and go back to our previous drawing here and look at the surface that it's built with our point cloud tool in Civil 3D using the kriging method. So again, I'm just going to go ahead and detach that and look at this. So, all right, so those are the results, and instantly you can tell that there's some difference in the way that it's processed the surface. And I actually think that this is the non classified data, but it's usually not as, let me just try this one more time. I'm going to go ahead and bring it in. Well, it is what it is. This is exactly what it is. So we took the same point cloud, we ran it through the Civil 3D tool to create the point cloud, and this is the surface that we get. So when you look at it and you look at the results between the two, this is why I use the LiDAR data and use the Geotiff. It seems like if you have classified data, the best approach is to build your surface from that using a Geotiff and extracting the ground points, and rather than bringing your point cloud in and using the method that's built into Civil 3D. The odd thing about it is this is the old approach. This is the old way. This is a functionality that's been around in Civil 3D for many years. And the newer way is the kriging method that will interpret the point cloud. And with that, you get, to me, it seems like worse results, not as accurate than if you just run it through the Geotiff. So, well, that's all I have. I think we can open it up to many more questions. Really, you can compare if we can do is we could load these two surfaces together or create the elevation difference between the two and look at and like calculate a volume between the two. But realistically, if we go to the statistics, we can get our median and max elevation here. And so let's just look, we're at 2661 and 2778. So let's look at what we built in our other guy here. Go to statistics here and look at our results here. So again, we're about a 2 foot difference on the minimum elevation and a couple feet difference on the maximum elevation as well. And so really what we could do is we could pull volumes. We could use one as our base surface, or we can create a base surface just out of a polygon and set it to our minimum elevation for our contours, and then look at the volume between the two. But really you can tell just by visually looking at this that one functions a lot better than the other, and you might get different results based on the process that you're using to generate your existing ground surface. All right, any other questions?
And also, guys, just one more shameless plug here for our YouTube channel. We have different playlists, and even on our Civil 3D playlist alone, we have over 130 photos, 130 videos. Reality capture, we have, 40, 50 videos. InfraWorks, we have a ton of videos on there. So it's a source of free knowledge. So, once that pandemic hit, we really fought hard to, even if we couldn't get on job sites and couldn't go out into the world and do work, we were doing hard work at home or in the office, getting you guys a lot of free, awesome content. So by all means, take a look over there. Again, youtube.com/ATG USA. And we have a lot of awesome content. So let's see. So do you want to take this, or I'll read it to you, Terry. So Joel says, so there was no good solution to create ground surface from the photogrammetry data with any Autodesk product. All of the methods you showed us all had problems recognizing or filtering out non-ground data.
Yeah, with photogrammetry, I think that's something that you expressed earlier as well. And just it's for photogrammetry, it's not going to penetrate trees, and so when you have vegetation, it just doesn't do a very good job not only classifying the data but actually reaching the ground. So if you do and you're able to extract the ground points, you'll have voids in your surface that it didn't get a ground point because you have vegetation. So you can imagine if you're in the Northwest and you try to use a drone to get a ground surface, it's just not going to work. It's not going to happen because none of the points are ever going to hit the ground because there's so much canopy. So I haven't found a good approach with Autodesk products. If you look at one of our webinars, there's an approach to that has more detail about the back and forth point editing within Recap, and that is very cumbersome. So I don't know of a good approach to do that.
Yeah. And just to let you guys know, as far as our drone data, we use SiteScan, which is an Esri product. I know there's Pix4D, there's a dime a dozen as far as different ones out there that'll process the photogrammetry. As far as within SiteScan, there are kind of little tools here and there, but at the end of the day, like we kind of keep patching on is it's getting, if there's a tree, that's what it thinks. That's all it sees. It gets the points of the tree and nothing underneath it. So you're not officially getting the ground. So that's where we're having the issues. Terry, we also have from Brian as well. Are there any tools out there that allow automated generating of break lines from surface data or semi-automated?
Yeah, actually, there is a couple, and they're in InfraWorks as one of the things you can do in InfraWorks is you can extract linear features, and basically what it's doing is tracing those lines. But when you say is it a good function? I haven't used it much, but I think there's other options to extract break lines from the point cloud surface. But one of the things that we can look into is, let me go back into one of our models here. And one thing you can do with the point cloud data as well is just is like cut cross sections on it as well. There's a couple tools on there. So I think what we can do is, if we go to the terrain tools and if you go to this vertical feature extraction, let's see. Maybe you can't with photogrammetry data. So not that I know of. I don't know of a tool that will easily extract break lines.
And then we also have a question from Adam. I don't want to butcher it. I'm not a civil guy, so if I say things wrong, but says, I have a TIFF file and a point cloud file. What is the point of the TIFF file? It is like a picture of a Lambert grid for the SHP file I'm using. Sorry. Okay.
All right, so you have a shape file and it's a Lambert grid. So there's probably no, I don't know if there's a relationship between the two. If you have a point cloud file, the TIFF file really, in the process that we've used is really creating a Geotiff. So it's basically an image that has elevations that we're using for the definition. It could be if you're talking about a projection, which is the Lambert grid. The TIFF file is probably just an index map or some grid map to show where the position of that point cloud is. But yeah, I don't have an answer for you. I'm not sure exactly what the TIFF file is. If it's not a Geotiff, if it's just a regular TIFF, it could be just a grid based on your projection or your coordinate system.
I guess, again, guys, we wanted to really focus on, I know it's kind of odd that we show you a photogrammetry data and show you kind of the pros and cons of what you're getting out of it. You'd be surprised at how this is the world we live in. And a lot of people are actually taking drone data and taking photogrammetry. And this is why we wanted to have this webinar is, yes, if everybody could do LiDAR scans for drone work and point cloud, everybody in the civil world would be a heck of a lot happier. But there's so many clients out there, companies out there that only have photogrammetry drones, because like I mentioned earlier, the price point is so much cheaper. For the price of one LiDAR drone, you could have a whole fleet of 20 photogrammetry drones. So in a perfect world, yes, LiDAR when it comes to this stuff. But there are little workarounds where you can use the photogrammetry, but we just wanted to show you, like, this is what it looks like when you do get that photogrammetry. And you can do everything that Terry showed you with a LiDAR scan and get so much better results. But we just really wanted to kind of have a preference here of so many people are getting their data as a photogrammetry point cloud. And this is how you have to kind of the workarounds and everything like that. So, but
all right.
Awesome, guys.
Thank you.
Yeah, we're at time. We appreciate you being here. Like I said, you'll get some information via email. Please stop by the YouTube channel. Take a look. We got a lot of awesome information there. Please go by our website, atgusa.com. Let us know if there's anything we can do to help partner with you guys. Deeper dives, let us know. Reach out to us on LinkedIn. Love to talk more about this. And if you guys have any workflows that can help us with any of this stuff, by all means, let us know. We'd love to hear. We're always trying to expand and everything like that. So, hold on one second. I'm struggling with this. Brian was saying, I'm struggling with this new way of working with drone data. It's as if we are compromising the way we do things. I appreciate the webinar. Good. Yeah. And Brian, like I said, that's what we're trying to do. We're trying to take something that's tough and rough and make it a little bit easier for you guys. But yeah, in the grand scheme of things, if you can get a LiDAR scan drone, it'll make your life a heck of a lot easier. So, but yeah, awesome, guys. Appreciate the time. Appreciate all the good questions and participation. And we will talk to you when we talk to you.
Thank you.
Hey there, thanks for tuning in. If you like this video, make sure to subscribe and check out some of the other content on our channel.